Okay, so welcome to all for the course of refrigeration and air conditioning. So my name is Professor Enis Iyer. Now we are going to study unit number 4, that is psychrometry and air conditioning load estimation. So in previous lecture we have learned about what is mean of psychrometry. Psychrometry is nothing but the study of properties of moist air. So moist air nothing but the combination of dry air plus water vapor. So in last lecture we have seen regarding that. So moist air, total pressure of moist air is equal to, that is partial pressure of dry air plus partial pressure of water vapor. So PT total pressure equal to PA plus PV. Now we are going to learn about psychrometric properties. So first property, dryable temperature. So dryable temperature is the temperature of the moist air measured by the standard thermometer or normal thermometer is nothing but dryable temperature. Next is relative humidity. So I define relative humidity as the ratio of mole fraction of water vapor in moist air to the mole fraction of water vapor in saturated air at the same temperature and pressure. So using the perfect gas equation, we can write that relative humidity phi is equal to me upon ms. That is the mass of water vapor, mole fraction of water vapor in moist air to the mole fraction of water vapor in the saturated air at same temperature and pressure. Or we define relative humidity phi is equal to partial pressure of water vapor to the saturation pressure of pure water vapor at same temperature. So we define phi is equal to partial pressure of water vapor PV upon saturation pressure of pure water vapor at same temperature, that is phi is equal to PV upon P saturation. So relative humidity is normally expressed in terms of percentage. So if relative humidity is 100%, it indicates that air is saturated. Next property is humidity ratio. So humidity ratio, we also call it as specific humidity. It is denoted by symbol W. So the humidity ratio is the mass of water vapor, mass of water associated with each kilogram of dry air. So assuming both water vapor and dry air to be a perfect gas, the humidity ratio is given by W equal to mv upon ma, that is mass of water vapor associated per kg of dry air. So W equal to kg of water vapor to the kg of dry air. So we define W equal to, by using perfect gas equation, so PV upon RVT, so PAV upon RAT. After simplifying this, we write PV upon RV upon PT minus PV upon RA. So ultimately we get the, so ultimately we write down W equal to 0.622 into PV upon PT minus PV. So W equal to 0.622 PV upon PT minus PV, where PV is partial pressure of water vapor and PT is total pressure. Now next property is dew point temperature. So what is the meaning of dew point temperature? So if unsaturated moist air is cool at constant pressure, then the temperature at which the moisture in the air begins to condense is known as dew point temperature of air. So the approximate equation to calculate dew point temperature is, so dPT equal to, this is 4030 into dryable temperature plus 235 upon 4030 minus dryable temperature plus 235 into log 5 minus of 235. So here in this case phi is the relative humidity and dryable dBT is dryable temperature. So dew point temperature is saturation temperature corresponding to the vapor pressure of water vapor. So dew point temperature nothing but the, if you cool the air up to that temperature, Then whatever the moisture content in the air, moisture in the air is coming out from the air. That is, air begins to condense, is known as dew point temperature. Next property, psychrometric property, degree of saturation denoted by symbol nu. So degree of saturation is the ratio of humidity ratio W to the humidity ratio of saturated mixture and WS at the same temperature and pressure. So mu is equal to W upon WS at same temperature and pressure. Then define next property, that is enthalpy. So enthalpy of moist air is the sum of enthalpy of dry air plus enthalpy of water vapor. So we define enthalpy of moist air is the enthalpy of dry air HA plus enthalpy of water vapor, that is W into H. So we simplify this equation. H is equal to CPT plus W into bracket HFG plus CPW into T, where Cp is the specific heat of dry air at constant pressure, Cpw is the specific heat of water vapor, where small t is variable temperature of air vapor mixture, W is the humidity ratio which expressed in unit is kg of water vapor per kg of dry air, which is the enthalpy of dry air at same temperature, Hg the enthalpy of water vapor at temperature T, and HFG is the latent heat of vaporization in kilojoule per kg. Now substituting the value of Cp and Hg, we write H is equal to simplify 1.005 T plus W into bracket 2501 plus 1.88 into T, or we can also write H is equal to 1.022 into Td trial temperature plus W in bracket HFG dP plus 2.3 TdP kilojoule per kg, where HFG dP is latent heat of vaporization of water corresponding to the dew point temperature. These are the formulas available to calculate the enthalpy of moist air. Now humid specific heat is equal to Cpm equal to Cp plus W into Cpw, where Cpm is humid specific heat, Cp is the specific heat of dry air, Cpw is the specific heat of water vapor, where capital W is humidity ratio. So second term in this equation is very small, like W into Cpw. So for all practical purposes, we consider humid specific heat of water vapor equal to 1.0216 kilojoule per kg of dry air. So humid specific heat is equal to 1.0216 kilojoule per kg of dry air. Kilojoule per kg Kelvin of dry air. Then specific volume is defined as number of cubic meters of moist air per kilogram of dry air. So specific volume equal to RAT upon P, that is equal to RAT upon PT minus PV. So we define V is equal to meter cube per kg of dry air, that is meter cube of moist air per kilogram of dry air. Then if you know any two properties, you can able to find out the partial pressure of water vapor. That is, if you know the variable temperature of partial pressure corresponding to variable temperature, if you know variable temperature, variable temperature, and total pressure, you can able to find out the partial pressure of water vapor. So by carried equation, PV equal to PW minus PB minus PW into TD minus TW upon 1544 minus 1.44 into TW. Here TW in this equation is nothing but the saturation pressure corresponding to vedible temperature that we got from steam table, and PB is a barometric pressure where small td is the tribal temperature and small tw is vedible temperature. So thank you for listening. So we have learned about in this video psychrometric property. So thank you for listening.